Um, I thought I would do another short video that just reviews some of the problems that we've done up until now. Okay, so I'm just going to the chapter test in the textbook and just working through some of these problems with you. So when you're doing a problem like question number 2, you're trying to do the square root of 242x squared. Okay, so what you're going to do is take the number, the 242, and break it down. And when I start off, I notice it's even. So I know it's 2 times 121. And I know 121 is a perfect square. So you could stop there. Or if you prefer going all the way down to the prime factorization, you would have 2 times 11 times 11. All right. So now we're trying to break down the square root of 242x squared. So looking at what we've got with the number, we see there's a pair of 11s, or that 121 is a perfect square. So we can bring an 11 out. Okay, underneath the radical, we'll still have a 2 from the numerical part. Then we look at x squared and we think about how it's a pair of x's, so we know we can bring an x out. So your answer is 11x square root of 2. And there's times understood between the 11, the x, and the square root of 2. And that would be the simplest radical form. All right, if you have a cube root, it's the same concept. It's just if it's a cube root, you're looking for not just pairs of factors, but you need 3 that would multiply together to make a perfect cube. So we'll do the same type of thing. We'll break down the 48. Okay, it's 2 times 24. We can keep going until we get 4 2s and a 3. Okay, so 48 is 2 times 2 times 2 times 2 times 3. Okay, now you got to keep straight what you're really trying to do here, which is cube roots. So you're going to think about it as 3 2s would have made the perfect cube of 8, and then you'd have 2 times 3, or 6, left. All right, so when we go to break down the cube root of 48 y to the 4th, we're thinking about how we've got a group of 3 2s, and think about that y to the 4th. You really have 4 y's there, so you have a group of 3 y's and then a leftover. So your answer is going to be a 2 out in front, because the cube root of 8 would be 2. The cube root of y to the 3rd would be y. Then underneath, you're going to have the 2, the 3, and the y, which would be 6y. Don't forget to put the index, the 3, in there. And that 2y is really times, so you can write it closer to the radical. All right. Number 4, you have a negative underneath a square root. This right here, for now, we would say is not a real number, because you can't find a number times itself that would be negative. Okay. All right, we'll go ahead and look at number 5 on that one. The fraction is underneath the whole entire radical, and you can't simplify the fraction, so I'm now going to separate it. In the denominator, I have a radical, but the square root of 81 is just 9. On top, the a to the 6th is a perfect square, and the square root of it would be a to the 3rd, and so your final form on that one would be a to the 3rd square root of 5 all over 9. Okay. All right, now 6 and 7 get into the fact that we have to rationalize denominators. So they actually come from that section 8.5, I think it is. So since I have a square root down there and there's no perfect square, it's not a perfect square, I'm going to need to multiply by the square root of 6 so that my denominator would become the square root of 36, or 6. But what would make that okay is if I multiply on top by the same thing. So I have 9 square root of 6 on top over 6. And then the last thing I look at is to see if I can simplify, and 9 and 6 out, the 9 out in front and the 6 on the bottom. That's an understood times between the 9 and the radical. So it is okay for me to divide by 3 on both of those and I'd have 3 square root of 6 over 2. Now, you'll never go in and divide like into what's under the radical and a number that's not under a radical. So you have to also know when to stop. That would be the simplest radical form. Right? And then let's do number 7, and then I'll go take a few more out of the chapter test. We'll continue. So on number 7, I've got 2 terms in the denominator. So what we learned to do on that is to multiply by what we called the conjugate. So same exact first and second term, but just opposite sign. So if it starts with a plus, put a minus. Then whatever you do to the bottom of the fraction, you have to do to the numerator as well. All right, so I'm going to leave the numerator in factored form. It helps me later when I have to simplify. But the denominator I'm going to FOIL out. So I'm going to have square root of 5 times square root of 5, which would be square root of 25. Then I'm going to have minus 6 square root of 5, then plus 6 square root of 5. Remember how when you multiply, how the insides can be put back together under the radical? So that's how we got the square root of 25. But how if you have something outside of a radical and something inside, they don't get, it's not going to become a 30 is what I'm trying to say. And then I have a positive 6 and a negative 6, which would be minus 36. Now, this concept of multiplying by the conjugate, we learned to do that because our answers can't have radicals in the denominator, and it'll get rid of that radical down there because the inside and the outside terms wind up being opposites that cancel out. The square root of 25 is 5. And so you wind up with 2 square root of 5 minus 6, all divided by negative 31. Really, I'd like to write that negative in a slightly different spot because I think it's best to put the negative up on top. It's more clear to people. But there's nothing common between the 2 and the 31, so that would be a good final answer. Okay? All right, I'm going to go back to the textbook now and just move to some problems past that one. Get to where we're kind of adding and subtracting. So here on questions like 10 through 19, let me see if I can make that smaller and snip that whole. Nah, won't let me. Let me see if I can do that. That's small. Nope. Okay, I can't make it any smaller. I'll just snip what I can. So let's go ahead and do some of these problems from 10 to new. So get some of these. We'll go from 10 to 17 from now. Okay. All right. So let's do a few more of these. All right. So here we're looking at problem or two where you're just adding and subtracting, like 10, 12, 13. But then on others, you have to multiply first before you add or subtract. So like on number 10, you already have like radicals. So to be able to add or subtract radicals, it's got to kind of be like it had to be back when you just dealt with variable terms. So you have 6 minus 3 plus 5. So that would be 3 plus 5. That would be 8. And it would be square root of z's. You're just really counting up how many of these you have. So 6 minus 3 would be 3 plus 5 would be 8 of them. And that would be your final answer. But when you get to a problem like 12 or 13, you don't have like radicals. So what you got to do is try to simplify the radicals first. And then if you have like radicals, you'll be able to condense them a little bit. Okay. So let's try number 12. So on that one, I'm going to take the square root of 50, t squared. Thinking about how 50 is 25 times 2. So it's a perfect square. So I'm going to get a 5 and a t out in front with a square root of 2 underneath. Okay. Then I'm looking at that second term, which was, I'll go ahead and write the minus t square root of 288. And let's see, 288 is 2 times 144, and 144 is a perfect square. So I can think of that as 144 times 2. And there was already a t out in front, and now there's going to be 12 coming from there, and then the square root of 2 left. And then see how this and this, okay, are the same. So these are like radicals. And so our answer would be 5 minus 12. So that would be negative 7t square root of 2. We were able to put them together. Okay. All right. Now, I don't think I'll take, well, maybe I will take the time to do 13 because I am trying to go back and touch on some things people may still be struggling with. So on this one, I'm expecting after I simplify the radicals that these might be able to be combined. So I'm going to think about 360, and I noticed 36 times 10, and 36 is a perfect square. So that's a good place to stop. Or some of you like to go further, but if you notice it, you got a perfect square, then you might as well stop, because then I know when I do the square root, I'd have 6 square root of 10. When I look at 250, I see the 0 and I think 25 times 10. So if I were going to do the square root, I would get 5 square root of 10, and that had a plus. And then isn't 40 4 times 10? Right? So this in between here was a plus. It was a minus. So that's going to be minus 2 square root of 10. And then they're all square root of 10s that I'm combining. So that's 6 plus 5, which is 11, minus 2 would be 9 square root of 10s. Okay. Now, sometimes on a problem, you might have a couple of them that turn out to be like radicals and then one that's not. Okay. So that's kind of just a recap of after you know how to simplify, then you might be able to just add and subtract. All right. Now, when we get to a problem like, let's do these in blue, like number 11 here, or when we get to a question like number 14 or 15. Okay. Right there, we've got to do some multiplying first. Okay. So let me clean off what I did in red, and we'll come back in and we'll look at the multiplying and dividing. All right. So I'm thinking, I don't know why this is so hard to erase. There we go. All right. Okay, so I'm thinking on number 11 how I ought to be able to distribute. And when you're doing these, think about how what's under the radical can be put back together underneath. And so on this one, you would get 4 square root of 6 when you do the first arrow, because square root of 3 times square root of 2 would be square root of 6. Then you would multiply the square root of 3 times 5 square root of 3. So the 5 is on the outside. There's only an understood 1 on the outside there. And then square root of 3 times square root of 3 would be square root of 9. Okay. Then you see if you can simplify more. But 6 is just 2 times 3. So there's no way to bring anything out of there. But square root of 9 is 3. So you'll have 4 square root of 6 minus 5 times 3, right? So that would be minus 15. And then these are not like radicals, so you'd be done. Okay. So it can get hard when there's numbers out in front and numbers underneath radicals. Okay. So it's best just to, as you distribute, to think about how what's underneath can be put back together, can be multiplied underneath the radical. So 6 square root of 2 times square root of 2 would be 6 square root of 4. Then when you do the outside 2, the 6 times 4 would be 24. The 2 times 5 would be 10. So you'd get 24 square root of 10, and that was a positive times a positive. Then I'm going to do negative square root of 5 times square root of 2, so it'll be minus square root of 10. And then a negative times a positive would be a minus. And it would be minus, and see how there's an understood 1 on that one. So it'd be 1 times 4, which is minus 4 square root of 25. Okay. All right. Then this square root of 4 would be 2. Square root of 25 would be 5. So we'll have 12. And then this is 24 square root of 10s minus 1 square root of 10. So now what we're thinking about is whether these can be combined. And these are like radicals. 24 square root of 10 and 1 square root of 10 are like radicals. So you'll get 23 square root of 10. And then at the end, we have minus 4 times 5, so that's minus 20. So we have just a little bit more to do because the 12 and the minus 20 are like terms. And so your final answer would be negative 8 plus 23 square root of 10. Okay. All right, let's take a look at 15 because this one gets people. You're not going to square just the first term and the second term. Be sure that you think about writing that out twice because that's what the 2 means. And then you FOIL it out. So you'll get a 9 on the outside, square root of 25. When you do 3 square root of 5 times negative 1, that's negative 3 square root of 5. Then you come back in and do negative 1 times 3 square root of 5, and you get another negative 3 square root of 5. Then negative 1 times negative 1 would be plus 1. Okay, so the square root of 25 becomes 5. So you have 9 times 5, that would be 45. Then you have minus 6 square root of 5, and then that plus 1. So the 45 and the 1 need to go together, making 46 minus 6 square root of 5, and that's not going to be 40 square root of 5 because there's no radical on the 46. So that'll be your final answer. Okay. All right. I'll go ahead and do these two. Number 16, when I look at that one, I realize I could put it back together under one radical and simplify a little bit. So we have 2m to the third n on top over 72m to the fifth. So before I try to rationalize and all of that, I'm going to see what happens when I simplify underneath there. So 2 would go into 72 36 times. I could knock out 3 of the m's, leaving me an m squared on the bottom. And then I would just have the n on top. Okay. All right. Then what I might do is, so that's where I'm at right now, is go ahead and separate it again. And if I needed to rationalize the denominator, I would, but the denominator would just be 6m with no radical and a square root of n on top. Okay. Then 17, it looks like I'm just going to FOIL. So I'm going to get a 16. I'm going to get a plus 12 square root of x, a minus 12 square root of x, and then at the end, I'd have a negative times a positive. So that's minus 9 square root of x squared. All right, so notice the 12 square root of x and the negative 12 square root of x would cancel out. Square root of x squared would just be x, and so I'd wind up with 16 minus 9x. Notice there's no radical left when I do that. If you look back at the two problems, the two binomials, they were actually conjugates, weren't they? So that's why that happened. Okay. All right, and then let me look at, I was going to try to do this video that reviewed some of the earlier materials since I did one on equations. Let's go ahead and do, we can go ahead and take a look at 18 and 19. And then the others are in another video. Okay, so let me just snip 18 and 19. All right. All right, so we'll look at those two, and then that'll be the end of this. So I just wanted to review the earlier sections on simplifying radicals, adding and subtracting them, and then multiplying and dividing them. All right, so on this one, we have square root of 2 over square root of 11. 11 is not a perfect square, but I need to do something to get rid of that radical. So I want to multiply by square root 11 down there. But to do that, I need to multiply on top. So I get square root of 22 on top over, and notice that square root of 11 is square root of 121. The whole reason I did it is the square root of 121 would be 11. Okay, so that would be the simplest radical form. When you're dealing with square roots and you're trying to rationalize, you basically can just multiply by itself. Now 19 has two terms, so I'm going to multiply by the conjugate. Okay, so square root of 7 plus square root of 3, and I'm going to do that top and bottom. And then I find that it's easier to keep it factored on top, but you want to go ahead and FOIL out the denominator to get rid of those radicals. So you'll have square root of 49 plus the square root of 21 minus square root of 21 minus the square root of 9. And so see how, because they were conjugates, how the middle term cancels out and how you have just 7 minus 3 really in the denominator, which is 4. So I have 6 times the quantity, square root of 7 plus square root of 3, and all of that's divided by 4. And because this is times, 6 is a factor of the numerator, I'm able to think about how 2 would go into 6 and would divide into the 4. So I have 3 times the square root of 7 plus the square root of 3 all over 2. That's going to be my final answer. Okay, that's simplest radical form. All right, so let me stop sharing this and I'll get it posted